Hello everybody, and thank you for joining us for today's DrayTek webinar. I'm Alex Shuker, Head of Product at DrayTek UK, and with me today is Lukasz, Waligorski, one of our product specialists in the team. Lukasz's main focus is kind of new features, firmware developments and products, but one of the things he looks at is technology, so that's why he's a really good presenter for today, which is everything you need to know about DrayTek with full fibre broadband. So today we're going to be looking at full fibre broadband and some of the things specific to making sure your DrayTek products are working great with it, so that you're getting the best service for your customers when it comes to speed. And we're going to be just going through some topics on that.
Thank you, Alex. So let's talk about different types of internet connections offered by ISPs. Then we will focus on the FTTP fiber connections, how to distinguish between fiber and VDSL installation, and what is the optical network terminal. There are many different types of internet connections offered by internet service providers. The very old ADSL is still available in some locations where around 20 megabits per second download speeds are provided. This service is now renamed to SOTAP, Single Order Transitional Access Product. It is still based on old telephone copper lines. And so is the VDSL, as known as fiber to the cabinet. It's now called Single Order Generic Ethernet Access that offers 80 by 20 megabits per second. And its faster version, GFast, that offers up to 330 megabits per second. The last two products use fiber that terminates at the street cabinet, from which old copper cable is reused. The limitation of that is the speeds, sometimes reliability, and mainly the distance. So if you are too far from the cabinet, fast and reliable connection can be actually delivered. So what we are going to talk about mainly is the fiber here, and why do we care about real fiber? So the key benefits are the speed, and it is likely to be more reliable service. There is no need for DSL modem. Just use your Ethernet router connected to the ONT device, which I will cover in a moment. Full fiber is quite complex to implement, largely using a technology called GPON, which stands for Gigabit Passive Optical Network, to share a fiber uplink between multiple premises, which uses a passive optical splitter, like a prism, to share the optical signal over multiple fiber strands. The ISP supply their own box, equivalent to a DSL or cable modem. It's called an ONT, or optical network terminal. This shared data goes to all ONTs connected to the fiber, but the ONT can only decrypt the encrypted data stream intended for it. No data intended for other ONTs. GPON implementation of FTTP gives around 2.4 gigabits of download bandwidth to share between all fibers connected to the main uplink, or more with XGPON, which is 10 gigabits GPON. And for upstream, data is sent on a different wavelength, so it can send while receiving on different channels. Each ONT gets a time slot to send data, giving around 1.2 gigabits per second upstream bandwidth for all connected lines. The endpoint link received at the premises is 1 gigabit up and down, but this is shared between other points on the main fiber. The line's data rate would also be set based on the package that the subscriber has paid for. This is the same as FTTC connections in that the fiber link is shared over many users, giving a contention ratio for the line instead of dedicated, but with much higher speeds and less contention, with far more capability to improve in the future. ISPs like Openreach will supply the optical network terminal, the ONT device, which will be configured to operate on the network. With the required pairing and configuration, the same as a Virgin Media cable modem, for instance. This means that full fiber internet in the UK, where you can plug in your own router, will normally be supplied as Ethernet. And it will be rare for fiber ISPs to provide a simple optical link and tell you to get on with it. One major benefit of this implementation is that the ISP can diagnose faults with the optical network far more easily than if the optical network terminal was simply left up to the customer. And in the rare instance that you do have a direct fiber optical link, you can use an SFP transceiver module with some DrayTek routers to convert the optical signals into Ethernet. Here we can see the Openreach diagram depicting use infrastructure. On the left, there is the ODF, which stands for Optical Distribution Frame, that is housing Openreach next generation fiber optic equipment. This may also include the DSLAM, GFAST, FTTC, and the FTTP. All of the above services are running through one of the NG boxes. ODF cabling with OLT, which stands for optical line termination, is held in exchange and together with one more WDM, that stands for wave division multiplexer, which is just a filter, mixing and unmixing connections, right? So they leave the exchange and typically go underground to connect to one of the CCJ's cable chamber joint. Here, Openreach will have different types of cables connected, usually yellow, black, and white. Then the link is made with the aggregation node. Aggregation nodes house all cables which come inside, make a connection, and go back off. Thanks to the fiber technology, the footprint of aggregation nodes has been reduced and is now usually in an underground box. And the fiber aggregation node can serve up to 13,000 customers. So once the fiber line reaches our building, it will enter into the small box on the left that they call the splice point. From there, fiber cable goes through a hole in the house, through the wall, where it is usually connected to the ONT device. If you are not sure what is currently installed in your house, have a look at the picture on the left. If a similar Openreach telephone master socket box is on your wall, it is likely that there is a DSL service that offers speeds of, on average, 80 by 20 megabits per second. And a smaller RJ11 cable will be used to connect your DSL modem or router. So it's still based on that copper line. Or if you have a newer installation, the ONT terminal that we can see on the right-hand side may allow you to browse to the internet over the RJ45 cable. The speed would significantly be capped much higher and may be capped at around 1 gigabit per second. So the ONT, let's have a closer look at the ONT box. It is quite small, okay, and there are only like 3 interfaces available. least in the one of the latest versions. On the right, there is the optical fiber ports, followed by the Ethernet ports, where your router is connected. And there is also a power port and an on-off button. So now we will talk about the compatible DrayTek routers and what to look at when choosing the right model. Then we will see how fiber cables are connected and what is the most common configuration required. I have also created a section where our current SOHO DSL routers are configured so that they can still be reused for fiber to the premises connection. Obviously subject to the firewall throughput capabilities. So here is our router comparison chart available on draytek.co.uk website. And you may have noticed that most of the routers come with a built-in DSL modem. However, Vigo routers offer the Ethernet backup option too. In most cases, this is compatible with the FTTP service. However, Vigo routers you got to focus on the speed available as well. So the next important section to check before upgrading the router is the total maximum firewall throughput. Most of our current routers can handle over 900 megabits per second, which is usually matching with the FTTP speeds delivered by internet providers. So why would you use a router that offers 1.3 gig or faster throughput? This is useful if an additional internet connection is considered for load balancing purposes. Here we can see our top load balancers. Each one is ideal for fiber broadband with performance options to easily handle gigabit with the Vigo 2927 series, and even faster on the Vigo 2962 and 3910, which I will detail in a minute. You'll notice that each of these are Ethernet routers, which can load balance one or more Ethernet 1 connections, instead of having a modem integrated for one connection. This is beneficial for load balancing. It gives you an upgrade path to any Ethernet modem or connection you want to use, rather than a fixed integrated DSL modem. The Vigo 2962 and 3910 routers are unique in DrayTek's router product line in that they have SFP module slots, giving the possibility of direct optical fiber links with a suitable fiber transceiver. Here's a table comparing each of them. The Vigo 2927 series is well suited for networks of 30 to 50 users with 2 gigabit Ethernet 1 ports, one of which is flexible, so you can switch it to a LAN port if needed, giving 6 LAN ports in total. It has wireless options available with AC and AX models, and the option for an integrated dual SIM LTE modem. The larger Vigo 2962 and 3910 routers are both rack mountable out of the box, but they don't have wireless integrated. Instead, you can use DrayTek's Vigo AP wireless access points, such as the Vigo AP 960C. It's the Wi-Fi 6 model. That's for wireless coverage in larger buildings where multiple access points might be more suitable. The Vigo 2962 caters for larger networks needing more performance with 2.5, almost 2.5 gigabit capability. It comes with a 2.5 gigabit Ethernet port to use either as a LAN or WAN, and it has an SFP module slot, which is shared with the Ethernet WAN port, giving 2 active connections for load balancing and 4 LAN ports. The Vigo 3910 offers extremely high performance and is well suited to large, more complex and multi-tenant networks, providing a mixture of 2.5 gigabit Ethernet, 10 gigabit SFP plus module slots, and gigabit Ethernet WAN ports, which can be set up to use as either LAN or WAN ports as needed, giving potentially 11 active internet connections or 11 LAN ports with a single WAN configuration. For the purpose of this presentation, I've picked the Vigo 2927 router. There are different versions, each come with the Ethernet WAN and great firewall throughput. So you can also get wired, wireless, LTE, and so on models. So let's talk about how to connect your DrayTek router to the FTTP service. The ONT device that probably has been installed in your property needs to be powered. Here we can see a white PSU cable on the left. The green plug on the right-hand side is our fiber cable that goes through the hole in the wall, and the middle yellow plug is to link your our DrayTek router here and the ONT with the Cat5 or Cat6 RJ45 cable. So connect the yellow Ethernet cable into the WAN interface of the DrayTek router. The other end goes to the ONT box provided by OpenReach. Now that the physical layer seems to be properly connected, let's log into the router. At this stage, I presume that your computer is also connected to the LAN interface of the router, and it loads the you can load the login page. So by default, DrayTek routers respond on 192.168.1.1 IP address. Now we can see the dashboard. Note that the 1.1 interface is green, so is the LAN port 2, where our computer or switch is connected. Go to WAN, General Setup page. Click on the 1.1 or 1.2 index, whichever you've used to connect to the ONT box. For most fiber networks in the UK and Ireland, no VLAN tag is required for internet. If VLAN tags are used by the ISP, they are usually handled automatically by the ISP supplied ONT. Okay, so to configure the router to not use VLAN tags on its Ethernet WAN port, and ensure that the customer and service VLAN tag insertion values are set to disable. A small note here that city fiber network do require a tag. Okay, there's always an exception. Probably you may find out that there are more. So for city fiber, when connecting to their network, they may ask you to use tag 911. This can be configured on a DrayTek router. Just set the service VLAN tag to enable and set a tag value of 911. But again, for most of the providers, we just stick to the VLAN tag insertion values set to disable, so no tag value. So once our general setup page is configured, we need to press OK. Don't reboot yet. Just go to WAN Internet Access, select the PPPoE from the drop-down Access Mode menu, then click on the Details page button. That will allow us to see this page where PPPoE tab is opened. Make sure that it is enabled and the ISP access setup credentials are entered. It is unlikely that the service name is needed above, so leave it blank. Now it's time to reboot. After probably about 10-20 seconds, you can log into the router again. And once it's responding, just go to the online status physical connection page to check the internet connection status. Okay, are DrayTek Soho routers compatible with FTTP? Yes, they are. And so let's have a look briefly at some additional configuration steps. Here's one of our 2760s routers that comes with a built-in DSL modem. As a backup option, one of its Ethernet LAN ports can be switched into the WAN mode, allowing you to connect the FTTP service. So go to WAN, General Setup, and click on WAN tool. By the way, same applies to newer models like the 2765 and 2766 routers. Set the enable option for WAN tool to yes. This enables the other options on this page. Active mode should be set to always on. Then press OK to save the settings and reboot the router. It should be ready to take that FTTP Ethernet cable now. So you can plug it in once the router reboots and then follow the configuration steps we just covered earlier. So now it's time to discuss the best practices and how to optimize your internet connection. We'll talk about the WAN connection detection settings. Then I will explain why it is important to enable hardware acceleration on your DrayTek router. And then I will help you understand the features which may impact the speed, such as the quality of service and LAN performance. Think of like 100 megabits fast Ethernet bottleneck. So DrayTek routers come with many WAN connection detection options. The first setup page that we usually configure is the WAN general setup page, enabling link condition detection mode to ping detect allows the router to report latency to Vigo ACS. Vigo ACS is our management platform. Cloud-based and self-hosted versions are available. Please note here that if there is no response, this feature does not bring WAN interface down. It's only for measurements and Vigo ACS purposes. Now we're looking at the WAN internet access setup page. The WAN connection detection highlighted section allows the router to sense if WAN connection is actually working. So make sure that a pingable IP address is used here. I have used IP addresses of the well-known DNS providers. And do you remember the comparison chart I presented earlier? The maximum firewall throughput shown here can usually be achieved when correct configuration is applied on the router, such as enabled hardware acceleration feature, QoS, wireless settings that we'll discuss later, and the right LAN equipment used. Okay, so what is hardware acceleration used for? It reduces demand on the CPU by offloading processing to dedicated resource. Optional feature that can be enabled on routers. Without hardware acceleration, the router CPU will do all the processing and is able to deliver decent performance and an array of features at the same time. But to increase the capacity, we can enable hardware acceleration, which allows the CPU to offload some processing to the hardware accelerator, which reduces the load on the CPU and allows some gains in top-level performance. Let's take a look at what this means in practice if hardware acceleration is enabled. The current range of products, the 2927, 2865, 2866, 2765, 63, and 66 obviously as well, can deliver up to 600 megabits per second. And with hardware acceleration enabled, over 900. Both TCP and UDP IP packets can be accelerated. Our latest range of routers can also benefit from IPsec VPN traffic, getting better performance. Note that non-IPsec traffic isn't hardware accelerated, nor is DNS and sessions to routers' local services. So when is hardware acceleration not needed? When your fiber connection is still based on DSL or FTTP that doesn't exceed 600 megabits per second, it is unlikely that enabling hardware acceleration will have any impact on your internet speed. How to enable hardware acceleration, you may ask? Well, that's a very good question. Navigate to hardware acceleration setup page. Set it to enable and select the TCP and other protocols. Press OK, job done. For more information about the hardware acceleration feature, and I can recommend Alex Shuker's webinar that covers HRM mechanism, CLI commands, troubleshooting, and many more useful details. Okay, you can also visit draytek.co.uk, the knowledge base article, the article section where you can read more about this. The next feature that can impact the speed of our internet connection is quality of service, or QoS. DrayTek routers offer extensively configurable and hardware accelerated quality of service with app-based QoS to easily prioritize important traffic for voice over IP calls, video chat, and gaming. Even the fastest internet connection can provide poor quality streaming and latency for gaming if it's in full use. Quality of service ensures less lag and better quality streaming for selected traffic, devices, or networks. DrayTek's latest generation of routers have the performance to apply quality of service to fiber internet access without throttling back speeds. We can enable quality of service for VoIP traffic with a single mouse click. For example, here, just navigate to bandwidth management, quality of service page, and check enable the first priority box. Click OK. There are other quality of service options like one QoS class rules or even app QoS that we can now see on the screen. The setup is quite simple. We can select the protocols or applications and assign them to the priority class. LAN performance, that's yet another important speed factor, which is the equipment really used on our LAN network. Our hardwired computer or a switch should support at least gigabit Ethernet. Otherwise, we may experience a bottleneck of 10 or 100 megabits per second, which is a fraction of FTTP available speed. The Ethernet speeds can be checked on the router too. For example, port status CLI command prints a good connection speed sync for LAN ports here. However, 1.2 seems to be limited to 100 megabits per second. We can manually force the device to use 1 gigabit. Don't forget to check the cables for any damage as well. So the printout of the port status command is on the screen right now. Now I would like to cover the wireless network considerations. There are some key points to remember when testing the fiber connection speed. First of all, use a cable, but if you need to run it over the wireless, pick the right router or access point. At this point, we know that what DrayTek routers firewall capabilities are, what are the maximum firewall speeds available on each model. So if we need to add wireless, just pick a Wi-Fi version, right? Well, yes, but which one? What does it mean when we see AX3000 or AC2200? We'll briefly cover the wireless technology and explain why it matters when connecting to the fiber services. So, which protocol is sufficient for gigabit fiber connection? The table lists all Wi-Fi standards, including Wi-Fi 6 that can support higher rates with theoretical speed from 600 to up to 10,000 megabits per second. In real-world environment, this is obviously much lower due to the overheads, obstacles, and interference. In fact, the connection speed is usually much lower. Here we can see Wi-Fi 5 laptop that managed to reach only 650 megabits per second link speed. On a different machine, Wi-Fi 6 adapter managed to sync at 344 and 685 megabits per second. So before we run a speed test for your internet connection, we should actually check Wi-Fi status on first. Now let's have a look at the theoretical physical rates. For example, the Vigor AP906 2.5 gigahertz supports channel bandwidth of 20 by 40, and 5 gigahertz supports channel bandwidth of 20 by 40 by 80, 160 megahertz. So the maximum rate assumes the highest modulation is negotiated. So here modulation used is decided automatically between the client and AP. And if the signal strength is worse, then a lower modulation is used. A lower modulation impacts the max physical rate we've seen that can be negotiated. To get the fastest speed, you need to use wider channel bandwidth. So 2.4 radio can be used with only 20 and 40 megahertz chunks. Hence, it is recommended to use 5G that offers larger channel bandwidth. And here is an example of the wireless APs. The AP1060 supports 4x4 that can give great speeds for a 4x4 client, okay? But for example, your iPhone probably handles 2x2 option only. So to get the fastest speeds to 2x2 clients, so we have two devices running 2x2, compared to a 2x2 AP with two 2x2 clients that will need to share the bandwidth. So if your AP supports 4x4, it can handle 2 clients with those with the 2x2 technology. If your slightly slower AP is running on 2x2, then obviously they will share the bandwidth. Now we are jumping into the troubleshooting section. And we're gonna cover the successful internet connection, speed issues, router cause issues, LAN, wireless again, and stuff. So first of all, make sure that all cables are firmly plugged in. LEDs on your ONT device and the one light on the DrayTek router should give us a clue if the cables allow traffic between both devices. Make sure that the Ethernet cable being used is of good quality and has all 8 wires. The dashboard should show the Ethernet 1 port in green to indicate it's connected at gigabit speed. If it's orange, speeds will be limited to 100 megabits per second. Once cabling is sorted, test the internet connection. If still failing, check the settings on the router. Here we can see the VLAN tag settings that should be set to disabled. And this is usually the only page that should be configured on DrayTek FTTP routers in order to get internet access. No typos allowed. Next one is if a fixed IP address has been specified for the WAN, try reconfiguring it to use no dynamic IP instead to check whether that resolves the issue. If it does, check that the correct IP address is being entered or check with the ISP. The speed issues, bandwidth management, and quality of service can also impact internet connection speed. So make sure that the correct value is entered. Here we can see that only 100 megabits per second is defined for the QoS feature, which may impact gigabit FTTP performance. Next one is the hardware acceleration. Make sure it's enabled. Click OK to apply the change, and acceleration should take effect immediately. New sessions will be accelerated by the hardware accelerator after just a few seconds, which should be immediately noticeable when performing speed tests or downloading large files. Some notes, the Vigo 2962 and Vigo 3910 users, these routers models employ a different method for hardware acceleration that is always on and does not need to be enabled or configured. Note, Vigo 2862, 2926, 2762 users, for hardware acceleration to take effect on these models, the quality of service, bandwidth limit, and data flow monitor must be disabled. So that's only on all the models. If any of these services are enabled, the hardware accelerator will not be able to accelerate packets. When enabled, the hardware accelerated traffic will not be counted by the WAN budget or traffic graph. And Vigo 2865, 2866, 2862, 28765, and 6 and 2 users only. When testing performance with hardware accelerator enabled, the download throughput is not accelerated to the full performance of your internet connection. It may be necessary to disable the 1.1 ports to achieve full performance. So to do that, go to WAN, General Setup, 1.1, and on there, set the 1.1 interface to disable. Then remember to click OK and reboot the router when prompted. Some more speed issues. When testing the internet connection, you may find that some or all websites fail to load. So make sure the testing computer's LAN IP address is correct. Here we can see the default 192.168.1/24 range with correct default gateway. Use a working DNS server that can be specified on Windows and other operating systems. Here we use Google's 8888 and 8.8.4.4 DNS addresses. Speed issues, the wireless. Your wireless network can obviously impact your FTTP internet connection speed. To diagnose the issue, number one, check AP reported status. You can use the link speed here. And something that many people forget to check, the client status. Again, this is Wi-Fi 6 module managed to sync at 300 by 800 megabits per second. So that might be a bottleneck. Okay. Check AP configuration. So use the maximum channel bandwidth that we briefly covered earlier. So use whatever is supported by your devices. And another thing is just to check if your client supports Wi-Fi 4, 5, or 6. How many streams are supported? Is it 2x2 or 4x4 module? It is worth actually checking the spec with the vendor. It is also recommended to check for interference. Are your neighbors using the same channels? You will notice that most of the DrayTek devices, wireless devices, including access points, they have some built-in tools. For example, the interference monitor that is available on DrayTek access points. So it's good to check what channels are available, what channels we should pick. So we need to check the signal strength at location. You could create a test SSID so that you can ensure which AP the client is connected to. Does moving closer to AP result in faster physical rates and achievable speeds? Compare the 2.4 and 5 gigahertz signal strength and any observation from channel load interference monitor. So all that may help you to troubleshoot and maybe fix the speed issues. So that concludes the last section before our Q&A session.
Thank you, Lukasz. It's been very informative. We've now got an opportunity to go through some Q&A session, any questions that you might have. So you're welcome to pop more questions in. At this point, we often get inundated with a bunch of others, but we've been answering some through. So we've got some we can start off with to answer over the audio. So Lukasz, I'll just ask some questions to you and then we can get started on that. So first question is going back to the GPON technologies. So in the presentation you covered mainly GPON. The question is, will there anything other than GPON be available in the future?
Yes, actually. I actually briefly mentioned that as well. So there's a faster version, XGS-PON will follow, and other similar 10 gigabit based products in time. Some of the altnet providers, like a smaller regional network operators are rolling out 10 gigabit base GPON from the start. Openreach will eventually move to this as well and are just conducting trials. So the exciting aspect of the 10 gigabit base ones is potential for high synchronous speeds in down speed and up speed.
Cool, thank you. And question about doing speed tests. So people often will do speed tests using the various different websites. You know, people Google speed test, and then you often have a few different things that will give good results. But question was if there's any plans to include a speed test application in the router itself.
Oh, right. The reason it's not included is that router's web interface would be a limiting factor here. Actually, it's just a mini web server. Purpose is to show the configuration page of the router. It's not been designed as a web server to handle high throughput, so a speed test would be limited by the mini web server rather than the router's firewall. That makes sense.
Okay. Yeah, thanks.
So please use the well-known speed test providers, probably 2 or more. Sometimes is good to get some average speed results.
Thank you. And now we've got, I think, what has won the award for the most popular question today, which is why isn't hardware acceleration enabled by default?
Oh, right. Okay. So that's way back in time. Historically, enabling HM meant less diagnostics, as if something went through the hardware acceleration, then we couldn't report the same level of diagnostics in session transfer receiving rate. Not so relevant on the current generations of routers like 2865 versus 2860. So again, maybe for more details, you can visit our draytek.co.uk website, where the solution articles are published specifically about the DrayTek Router 1 performance and hardware acceleration.
And on that, I will post the link to that webinar into the chat if I can find the way to post something in the chat. So I'll do that in a second. Next question is about the clients. We talked about 1x1, 2x2, 4x4. I think you covered it, but could you just explain what is the differences of those numbers? What do they mean?
All right, so it's seeking numbers of streams. So the X by X number, 2x2, etc., is the number of streams that are supported. The total throughput would be the combination of the stream speed. So a 4x4 client could provide up to 2.5 gigabits per second at 80 megahertz, and half of that on a 2.2 client. Most phones are 2.2 max, okay? So, and most laptops are 2x2, but some PCI Express cards are widely available, and they can handle 4x4 speeds. So it is possible to actually use the max number of streams here.
If you really want to maximize the wireless sort of thing, yeah. The related to that, you I think covered recently about that you could just look up the chipset on the laptop. If you look at the wireless properties, you can see the version and then go to the manufacturer site, and they'll often be able to explain exactly what the capabilities are and whether it's 1x1, 2x2. Sometimes it'll display it on the machine as well itself. But yeah, okay, that's good. The next question is on here. Let me take a look. So there was some things about the WAN setup. There was a couple of comments about that there are sometimes some situations where different tag is needed, which is true. So on Ireland, the tag of 10 is needed, and also with City Fibre, there is a tag which
I think it's 911, right?
Yeah, that's 911. That's right. Yeah. So that's the thing. That we've got a guide on the website that does explain some of the differences. I'll post a link to the general WAN setup guide that you covered in there as well. There's a question about the MTU value. So for FTTP, there's different MTUs like 1500 or 1492. Question is, why is it sometimes 1492? What's the reason for the dropping the 8 bits, and what value would you recommend having set?
Probably most of the time try to put as high a number as possible, which is probably 1520 now. But if it drops, if you experience some issues with connections, etc., you may gradually drop it and see how this goes. There shouldn't be much of a big difference in the speed, etc. So it's safe to play with this tool, and there's actually a testing option as well within the DrayTek router.
Oh yeah, that's what you mean by drop, isn't it? Because it's if the MTU is set to be too high, then what you get is fragmentation, where the router has to send 2 packets and then it gets reassembled. So it has to split up. If the packet size is bigger, then it has to cause fragmentation. And if we set an MTU that's too low, then it causes fragmentation. But also it needs to be an MTU that's supported. Typically on most connections, certainly the OpenReach ones will support up to the 1520, as Lukasz says, but you lose 8 if you're using PPPoE. So if you can use DHCP as an option, if you had a choice between DHCP and PPPoE, then DHCP or static dynamic better, because you're not losing 8. So there's no kind of that penalty of the 8 for the PPP header. But yeah. Okay, and I think that we might be able to close it there. Do we have any other questions? Oh, there was some comments about the whether or not SOTAP and SOGFAST are available yet. They're, I think, technically not launched by OpenReach, but they're kind of in their plans. Whether or not we actually see them but will come in time, because at the moment people can still order the existing variants of those if they're in the footprint area where their property has that. But it may be that OpenReach don't launch those products. It depends a lot on their FTTP rollout and how much coverage they got and what they have on that. But I think we can probably wrap it up there. It's coming up to getting to 11, so that's how long we said the webinar would be. So I just wanted to finalize by thanking Lukasz very much for the presentation. It's been very informative, and thanking everyone for attending, and thank you for your questions. We've got through them. We'll try and if there's any we haven't been able to follow up with, then we'll try and follow up with you afterwards. But yeah, thanks very much. We hope you found this interesting, and do give us any feedback on other presentations you're interested in, areas that you'd like us to go into more detail. We'd be very happy to focus on those in the future. So thanks everyone.
And guys, have a good day.